Okay, let's get to it. Math Foundations 3. Now, I'll just share just two thoughts on why I'm streaming this. The first is give you a sense of what it looks like to be working on MathAcademy, just if you're curious about what it looks like, what a practice session looks like. The second thing is actually just, I'm hoping to model good behavior of what a good practice session looks like. So if you see me mess up or struggle or something, and how I recover from it, hopefully, and just my general demeanor, hopefully that gives a good example for everyone else who's working on things of their own. So with that, let's get started. Move this over a little bit. So today so I finished Math Foundations 1 by just testing out of it. I tested about 70% done with Math Foundations 2. It took me about 2 months to work through and earn just over 2,000 experience points, finishing out Math Foundations 2. I'm now in Math Foundations 3. Last time I streamed, I just got into it, and I was like 3% done. And then I took a diagnostic on the Math Foundations 3 because I felt like a lot of it was familiar to me. And I tested out of, I guess, 61% of the course, so I'm 61% complete now, even though like last week I was only 3% complete, because I'm coming back to this is more of a relearning for me than a learning. So let's get started with the first lesson. I usually like to start with review, but I guess I only have lessons up, so let's get started. Now, take the transpose of a column. You go through here. It switches. Yep, okay. Find the transpose of that. Okay, I think I get this. So it's just the kind of a rotation that way. So I'm just going to go 103 minus 412. Yep. Oh, wait, did I not get this right? Minus 4 goes to the lower left. What does it say? Oh, I just did it. Yeah, oh, of course. Okay, so let's think about this. Yeah, the column just becomes a row, so that's okay. Well, okay, my perfect streak ends with the first question going down. Okay, so what's the transpose of this one? It's going to be negative 2, 3, 0 along the top, negative 1, 1, 2. Okay, now this is correct. Okay. This is why it's good to warm up. If A transpose, so 5, negative a half on the top, 2, 0 on the second. The negative sign hasn't screwed me up, right? Okay. Transpose. Okay, bit of a drinking problem there. What's transpose? Make it a column vector. Yep. L transpose negative A, B, minus C, D. Is just the same order, just the thing. Minus A, B, minus C, D. Oh boy. 1, negative 10, 100. Okay, so this is a 3 by 4. 3 by 4, so it goes by 4 by 3. Yes. 1 by 3. So it goes 3 by 1. Again, 3 by 1 goes to 1 by 3. Properties of the transpose. The diagonals stay the same. Everything else is flipped across it. Yep. Transpose is the same. Complete the lesson. Got one wrong, so no extra points for me. Okay. Let's keep going. The minor of the entry is the determinant of the remaining entries when the row and column containing ij are removed. Suppose we want to do the minor of this one. find the minor. Everything else is gone. We're left with a 2 by 2 matrix, and then we have to do the determinant, which is the diagonal minus the diagonal. So what is the 3 by 3 matrix with integer entries? Determinant of 1, 5. So it's 2 times minus 35, so negative. Yep. Okay, this looks reasonable to me. Calculate the minor entry of calculate the minor of the entry C22, which is the 57th thing in the matrix C. Okay, so let's first draw this one. 20, 0, 6, 57, negative 9, and 12 minus 6, 4. So 2, 2 is this guy. So this whole row and this whole column, row and column, get out. So we have to do the determinant of 1, 0, 12, 4. So this is determinant of this, which would be 4 minus 0, which is 4. Okay, I think I get it. Minor of the entry D23. Okay, just make sure I'm counting this right. 23 would be, so this would be 1, 2, row first, row 2, row 1, column 2. Okay, so 2, 3 would be row 2, 3, so 33. So can I get fancy? All right, now let's just do it. We've already made one wrong this morning. You don't get a chance to be too fancy to start out. And 25, 30, and 41. So the minor of D23 is row 2, 3, this guy, which means that guy and that guy are gone. So we're looking for the determinant of 10 to 25, 30. So it'll be 300 minus 50, 250. Correct. Okay, now do it with the variable entries, okay? Like this, slowly building up of the difficulty and everything else. So what is the minor of C22? So 22 is x plus this thing. Remove everything else, do the determinant as normal. Okay, so let's give us a real one. Minus n, m minus 2n, mn, m plus n, m minus n, minus 20, 3n, 3m. Okay, we're looking for row 2, column 1. So this guy means that what we're left with is n, m minus 2n, 3n, 3m. And we're doing the determinant of this guy, which is 3mn minus 3n times m minus 2n. And I guess they want us to actually reduce it a little bit. So 3mn minus 3nm plus 6n squared. So 6n squared. Cool. I am going to watch myself go live here and look at the chat here if there's any chat situation. Okay, so question 3 correct. What is the minor of this? Now I'm feeling like I've warmed up a little bit. I might be able to actually go a little bit faster without doing some mental math rather than write everything out. So row 2, column 1, so that guy's gone and that guy's gone. So we're doing j, k minus 2j, and then we jump down to here, minus k, and j. So what's the minor of this thing? So we do the determinant of this guy. So it's j squared minus negative k times k minus 2j. So this part is negative k squared. And this part is positive 2jk. And it's j squared minus this. So let's just go through. J squared plus k squared minus 2jk. And I guess they're saying we can do a different, we can do factoring of this. That would be j minus k squared, I think it is. Because then I would get 2jk. Yeah, I'm going to do this. Right on. Question number 5. So the minor is minus 6. All possible values of k in the matrix. Okay. So negative 6 equals the determinant of, and it's 3, 1. So row 3, column 1 is gone, meaning we're left with just the upper right-hand corner here. 4k minus 2 minus 2k plus 4. 4k plus 16 minus negative 2k plus, so it's minus plus 4. So that would be 4k plus 16 plus 2k minus 4. So that would be 12 plus 12, and this is 6k. 12 equals negative 6. From above, so subtract 12, we get negative 18 is 6k. Do we have any squares or anything like that? No. K is simply negative 3. All right. Last one if I get this one right. Then I can do a victory lap around the chair. The minor of S33 is 24. What are the all possible values of W? Okay, so 24 equals the determinant, I gotta work on my handwriting, of 33. So 33 is the third row, third column, so just the upper left-hand quadrant is what we're dealing with here. 3W, negative 6, 12, negative W. 24 equals negative 3w squared minus, well, so it would be plus 6 times 12 is 72. Okay, so subtract 72. Let's just do it this way so we don't mess it up. 24 minus 72 is negative 48 equals negative 3w squared. W squared equals, let's see, 16, which means W equals plus or minus 4. Completed, and I got all those questions right at least, so that means I will have bonus points of +2. Time for a victory lap around the chair. I have 16 out of my goal of 15 experience points. So this deserves a victory lap. That is enough celebrating. Time to get back to work. Okay, so I've been going for about 15 minutes so far, and I got 15 experience points. So far it's about 1 minute per experience point, at least at this stage in the Math Foundations thing. While streaming, so I'm going a little bit slower because I am trying to talk through some of my thoughts as we go through. I'll do maybe another 15 minutes or so, and then I'll stop and have this like a good half-hour session. We'll see how far we can get. Let's just go with the next lesson. Cross product of two vectors. Two vectors is a cross b, magnitude ab times sine of the theta between them. N is a unit vector that is perpendicular to both a and b. Okay. A cross b, blah, blah, blah. And we have the right-hand rule come in. Is a vector quantity. Calculate the cross product of two vectors whose angle is a special angle. Okay. Sounds good to me. All right, question 1. U has magnitude 6. So V is magnitude 6, okay. Theta is 135, okay. And N is the thing, in terms of N. So 36 times the sine of 135 degrees, which would be 45 plus 90, so we're over here. So this is 45 degrees, so this is 90 degrees. So root 2 on 2. And it's sine, so it's positive here, so I would say 36 times root 2 on 2 n hat. Or just doing n vector right now, but it's a unit vector, so it's okay. So we got 36 over 2, which is 18 times the root of 2 n vector. Final answer. 4, 3, angle 60. Yes, yes. I see the chat is trying to race me. I have a little bit of a advantage, I guess, because I think it's about a 10-second delay, it looks like, between what I see here and what I see in the chat. Okay. I see the chat on this screen, by the way, so if I'm looking here, I'm not cheating and getting answers from the chat. Don't worry about that. So the vector angle is 60, so angle 60 means that it's root 3 on 2, so 12 times the square root of 3 on 2, which is, this is 6, times root 3. N, of course. 6 root 3 with the n on it. Non-special angle, you have to do a miserable calculation with a calculator to get that. Vector u2, vector 30 times the sine of 71. Let's just do it here. 30 times the sine, and we're in degree mode, 71. 28.366. So we're just going into one decimal place, so 0.4. Magnitude 2 and 10, 15. Round it to the nearest answer. All right, let's go faster then. 2 and 10 is 20 sine Missed it. Times sine of 15 degrees, 5.2, 5.18. Oh, were you late on that one? Yeah, you got E on that one. How'd you do on question 4? This isn't a race. We're all here to learn and have fun. It's a little bit of a race. I like my chances, though. I get a head start. If it's perpendicular to 0, understood. Sine of 90 is 0. No, sine of 90 is actually 1. Anyway. It's the 0 thing. 0 means that the cross product is 0. Yes, I understand. I said it wrong. I promise I understand it. The angle is 0, so the cross product is 0. See? Look. See how well I understood it? It's by itself, so there's no angle between them, so it's, again, 0. See? Told you I understood it. And completed the lesson. Okay. One more victory lap. Perfect score. Experience points up to 25 out of 15. I'm now estimated to complete Foundations 3 in, what does it say here? July of 2025 at my current pace. Oh, by the way, this is the diagnostic. I actually took it over Saturday, Sunday, and Monday. So it took it 3 days to do the diagnostic and gave me a lot of experience points for doing it, but that's why it looks like I have a hole there. I didn't complete the diagnostic on those days. Okay, what do we want to do next? This is going to be the last one, so let's pick a fun one. Integration by parts is not fun. Limits of radicals, approximate functions, determinants of a 3x3 matrix, differentiating an inverse function at a point. Let's do that one. Consider the function. F of x is 4x squared. Yes, you can use a calculator for these. And I have my little screen here of what I've used it for so far. This first one is legitimately lame, this minus 48. But I just didn't want to get it wrong because that was one I'd already gotten one question wrong for. So let's just make sure I don't make a silly mistake. Domain restriction means f is invertible on its entire domain. Okay. Start with p. 214. On the curve y equals f of x, that means the point p prime. On the inverse is over here, 14 and 2. That makes sense. Then y equals, well, I guess the blue y equals f prime of x. I wonder if they are thinking that they should call this y prime here. Very minor point. Very minor point for the pedantic ones here. How do we find dy dx at the point p star or p prime? We just take the slope of the tangent at that line. It's the reciprocal of the slope of the tangent at f of x. Yeah, makes sense. Calculating dy is straightforward. Differentiate y. Plug in gives x of 2. Then we take the reciprocal and do that. So we can summarize the process by using the following formula. The inverse function, the derivative of the inverse function of x is equal to 1 over the derivative of the inverse of x. To help remember this formula, note that it's okay to swap the derivative symbol, the prime, with the inverse symbol as long as we take the reciprocal afterward. Let me think about that for a second. We can swap them as long as we take the reciprocal afterward. Oh, okay. Is it just saying that f prime minus 1 goes to 1 over the inverse of this, like this? And vice versa? So f minus 1 prime 1 on f prime is this doing with this? Yeah, okay, that's what it's saying. Okay. I might take a second on this one. Inverse of a function from a graph. Okay, the graphs are easier. Why is this? Why is that? Blah, blah. Coordinate of f inverse of x if f prime of 2 is negative 3/2. What's f prime at 0 at the negative inverse of that? So 2/3. Oh, it's just the inverse. 2/3. Yeah, we're not taking the tangent curve, taking the normal of it. We're taking the inverse. So the inverse means it's just 1 over. So 2/3. So negative 3/2 goes to negative 2/3. Okay. Oh, good. We have to use a graph first. Point A has coordinates 1, 0, lies on f of x, given that 0, 1, lies on the inverse. Oh, okay. What is f, the inverse of the derivative of point 0, which is 1 over, simply 1 over the derivative at here. So this looks like it goes down 2 every 1 it goes over, so it's a negative 2, so I would say negative 1/2. And we have the same thing with this kind of thing. B has coordinates 2, 1, 1, 2, okay? If f prime of 1, so we're looking at this guy, is negative 3, what is it at 2? What's the inverse at 2? So just literally 1 over that. So negative 1/3. Like, they call it scaffolding on this, where it's like they kind of level it up with like one kind of small step at a time to kind of get you to the next one. It's a very nice experience on the learning side or the relearning side. It's just like, yeah, okay, it's just the one thing, and keep adding to it. I think it's very thoughtfully done, and it's a very nice experience from the learner's side. Consider the function blah and the point blah that lies on f. F of x is invertible. In the vicinity of p, determine the slope of y at the point -5, -1. Can I guess what it is here? So, okay, it's just this. It's the inverse point. That's the one that matters. It is invertible. Okay. What's the slope of it? Okay, so I guess they start by saying, let's do the derivative at the point -5. -1, -5. Okay. Okay, I think I get what happened there. Okay, question for me to demonstrate that I've actually learned it. Let's try it. F of x equals blah, and the point lies on this, the invertible in the point P. What's the slope at this, which is a point -5, 0, which isn't. They're not trying to trick me there. So f of x equals 3x cubed plus 4x squared minus 2x minus 5. F prime of x equals 9x squared plus 8x minus 2. F prime at 0 means f prime at 0 is 0, 0, 0 minus 2, which means f, the inverse of this is 1/2, negative 1/2. Okay, that seems reasonable. I'm getting what's happening. Okay, the point 21,4 was the point of this thing. It is invertible. That is the inverse of that point. Okay, no tricks there. We're just going to have to do the derivative, which is 3x plus 1 to the 1/3 power. And so this would be 1/3 3x plus 1 times 3, which means that goes away. F of x at the initial point is 21, it looks like. So 3 times 21 plus 1, which is 63 plus 1 is 64. Did not do the correct thing here. 1/3 this to the negative 2/3 power. 1/3 minus 1 is negative 2/3. Okay. So that 3 cancels out correctly, but we need to redo this. What is 64 to the negative 2/3 power? So cube root of 64 is, goodness. So this would be 16. No, this is simply 16 because I did the negative 1 over this. Oh my god. 1/16. Come on, Jonathan, focus. Still wrong. It's not even an answer. I didn't even do this. I didn't even do it wrong in the usual ways of doing it wrong. This is a big fail. Jonathan, focus. Do this again. We have 3x plus 1 to the 1/3 power. Then we do derivative of this. So it's 1/3 3x plus 1 to the 1/3 minus 1 is negative 2/3 power times the inside of the thing, which is 3, which means this cancels that. Okay. The x value of the original point is 21. So we do 3 times 21, which is 363 plus 1 is 64 to the negative 2/3 power. Let's do negative 2/3 power. Oh. And the reciprocal of that is the reciprocal of this. Okay, so it's what we want is the invertible functions thing. So it's 2/3 is 1/16. Okay, so that is 1/16, which means the answer is 16. Boy, if you came along for the ride on that one, what a roller coaster. Is there some clever way of doing this, like 64 to 2/3 without like just doing an annoying amount of math? 4 times 4 times 16 times 4 is right, it's, yeah, oh, it's 64. For some reason I convinced myself it wasn't 64, the 4 cubed. Okay, so that makes it easier. It must be. So cube root of 64 is 4, and then square it, so 16. Alrighty. Now we get to use tables to do derivatives. F of x, f prime of x. Use this data to find f prime, blah, blah, blah. Recall the formula of the inverse is this. Recall it. Substitute x equals 1. For the table we get 2. 2, therefore it's 1 over that. We can also use the rule for calculating derivatives of inverse functions in conjunction with other rules of differentiation. Let's see an example. I have to admit, there is a lot going on in this one. There is a lot going on in this one. We have some f specified with evaluated at a couple points, 1 and 2. F of 1 is negative 1, f of 2 is 1, f prime of x is 2, f prime of x at 2 is negative 1. And we have a g of x, the same thing. Find inverse f times g derivative at 1. Okay, so f prime of g is g over the inverse thing, okay. And then the product rule gets us, the product rule gets us 2 of them. Okay, and then substitute in for 1, plug that in, and then from the table, just do replacements, therefore for negative 1. Okay, this is going to be the last lesson I do for today, because I can already tell that keeping track of this is beyond my slightly sick brain to think through. So what do we have here? F of x, f prime, g of x, g prime of x. At some point, so we're looking for g f inverse prime at 4. So it would be g prime f in, negative 1 plus g times f1 prime and this means that this goes to g over, we can do the reciprocal thing where this ends up being the reciprocal of f prime g prime f inverse. Okay, so that would be at 4 g prime at x is 1 times f inverse, which is 1 over at 4. Okay, this is where it's getting tough. F, from the table return f inverse of 1 is 2. Do we see that from the table? This is f prime of x is 2. Am I missing something here? Prime of f negative 1 of x. And that's what this part is. think the only thing I'm not tracking exactly is why we know that f inverse of 1 is 2. How do we know this part? I think the rest of it I get. What is going on here? Blah, 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 blah. So, okay, let's look back at this question here. Let's solve this part and then get going to it. The derivative of that 4 means that it's 3 over, start from the inside, f inverse of x, which is 4. Yeah, I'm missing something here. We have f and x prime, f and f prime. Use this data to find f inverse. Recall that the derivative of f inverse is 1 over f of f inverse. So we have this. From the table, we obtain that f inverse of 1 equals 2. I see. That's because f of 1 is 2. F inverse of 1 is 2. Is that because we say f of 2 is go back to 1? And f prime of 2, I mean, this part's easy. F prime of 2 is 12. That's easy. You just look that up. And the inverse of 1, f of 1 is 2. So the inverse of... okay, so it just goes back to that one. So do we have the same thing happening here? Well, I guess we do have something like that. So because we can do the inverse f minus 1 of 1. So that says we want the inverse of 1. So that would be, you go to here and it goes to 2. Okay, just do the inverse, Jonathan. Just do the inverse. Not so hard. Okay, so the inverse of 4 would be, okay, so that would be the inverse of f inverse of 4 is minus 3. So this goes to negative 3. And we need to do the f prime of minus 3. So f prime of minus 3 is 5, which means that this whole thing turns into 5. Whew. Okay, so 3 over 5 is the right-hand side. Good gracious. How do we do the left-hand side? It is g prime of x, which which times the inverse of it. So inverse of, again, 4 of x inverse g prime of 4 is 1. Inverse of f of 4 is minus 3. So it's negative 3 plus 3/5. Oh boy. So that's negative 15/5 plus 3, which means it's negative 12/5. That was correct, and I actually think I really get it now. But boy, that was a bit of a headache. All right, let's finish out this lesson and be done with it. Okay, I think I fully understand what's happening, though. That was a good one to go through kind of slowly, because now I'm seeing what they mean by doing the f inverse. It's obvious. You just look up the inverse. You just do the inverse function of what it is. You just do the math like it's described. Okay, f of x, f prime of x at some points. What is the f minus 1 prime of 5? Okay. So f minus 1 prime is 1 over f prime f inverse of this. So f prime at 5 is 6. And we have to do the inverse of 6. 1 over the inverse of 6. So f prime of 5 is 6. So what is the inverse of that? Maybe I could just do it directly. The derivative of and the graphs I have such an easy time with. The tables, man. Tables are tough. Following the tables gives a value of f of x. If f of the inverse f derivative f minus 1 prime of x is equal to 1 over f prime of f 1 of x. Let's go back down. So f inverse of 5 is 8. So f prime of 8 f prime of 8 is 4. So that's 1 over 4. Just apply the formula, man. What did I get wrong here? The derivative of the inverse is 1 over f of the derivative of the inverse. Okay. One more time. Let's keep going. Finding the derivative of a property of the inverse functions. Fx is invertible throughout its domain. What is f? The inverse f prime of 2. Okay, I think that makes sense. Let's try it out. F of x is 3x plus 1, 2x minus 1. What is f negative 1 prime of 2? This would be equal to f, what I do here, prime of f negative 1 of 2. Okay, so let's just see. What is the f inverse of 2 is equal to? Which means, I guess, implies actually. Two equals 3x plus 1 over 2x minus 1. Multiply both sides by 2x plus 1, which would be 4x minus 2 equals 3x plus 1, meaning this is x at the 2 on this side equals 3. 3x plus 2, x equals 3. So f prime of 2 is 3. Or x equals 3 for that. Therefore, f prime of 2 as follows. We have this function Did I mess this up the wrong way? Oh my gosh. Give me 1 second. Calculate the value of f inverse 2. To do this, we write the equation f inverse of 2 equals x. I should do the same thing. F inverse of 2 equals x. Because that means then f of x equals 2. And then f of x is what I just did up here. 3x plus 1 over 2x minus 1 equals 2. Which then means x equals 3. Okay. Therefore, the inverse function of 2 equals 3. I think that's right. Now we calculate f prime of 0. By just doing the derivative. Okay, so let's just do that. We have it at that exact point. So f of x equals this. F prime is derivative rule. Let's do this one. It's minus 2x times 3 over 2x minus 1 squared as low d high, so it's high d low, so it starts off with 3x plus 1 times d low, which is 2. Okay, let's reduce this. 6x plus 2 minus 6x plus 3, because minus the negative 3 over 2x minus 1 squared. These cancel, these add, so it's 5 over this. And we actually need it only at the function at the value of 3. So we go 5 over 2 times 3 is 6 minus 1, which is 5 squared. So 5 over 25, which is 1/5. And negative 1/5 is the only thing I have here, so it means I've messed up a minus sign somewhere. Have I messed up a minus sign somewhere? High to low. Minus low d high. Okay, I'm going to go with minus 1/5. And if this is wrong, oh, I did something very wrong. I need to spend some time thinking about this one. So what did I do wrong here? I'm definitely going to learn something here. So, okay. F of x invertible f minus 1 is this thing. So to do it, we do this. Okay. First we calculate this thing. To do this, we solve the equation f this equals x. We did this. F of x equals 2. This thing equals 2, which means x equals 3. Okay, so up through here, I have it right. Okay, so then we do, yes, f negative 1 of 2 equals 3. Okay, so through here, I've got it right. Now I calculate f prime of 3. Okay, which is 5 over 2. It's negative 5 over 2x minus 1. Okay, so I have the minus sign wrong there. But then I just plug in 3, so it should be minus 1/5. Okay, so I said I got the minus sign wrong. Oh, of course. And we plug this back into the thing at the very, very top here. It's 1 over that. Oh, that one hurts. That one hurts. I did all of it right, except the stupid reciprocal at the end, which is crucial, obviously. Okay, well, okay, at least the problem isn't conceptual or something else. I do need to figure out why I got the minus sign wrong on this one, though. All right, so before I move on, I want to actually just recalculate that. F of x equals 3x plus 1 over 2x minus 1. F prime of x equals, so it's, I remember it with like low to high minus high to low. Oh, is that it? It's low d high minus high d low 2 over low squared. Did I just flip it at the very first step? I just flipped it at the first step. Okay, so that gives you the minus sign. Okay, so that minus sign was, I just wrote down how I thought about it wrong. Okay, so not a conceptual problem, just a carefulness problem. Remember the reciprocal, Jonathan. Remember the reciprocal. Okay, that one was painful. That one was painful. And I have an extra problem to solve because of it. Okay, f of x equals x plus 2 times the natural log of 2x plus 1. Its domain is whatever, so determine f prime, already got it wrong, f minus 1 prime of 0 equals what? And I'm going to make this like a big boxed thing that I have to go to before I answer. Okay, from memory, Jonathan, can you do, what is the formula of this? F minus 1 derivative of 0 is equal to the inverse of f prime of f inverse of 0. Okay, we have f of x, and so we need to say, what is f, the inverse of f of 0, which means 0 equals x plus 2 natural log of 2x plus 1, so that at the end of the day we'll have, so this is what x gives us the output of 0, which means that the inverse of 0, the inverse function of 0 gives us that x. Okay. So this gives us 0 when x plus 2 equals 0. So if x equals negative 2, that gives us 0. If I put x equals negative 2 here, what happens? Negative 4 natural log of this thing. So this is not a valid solution. So when does the natural log of 2x plus 1 equal 0? It's when natural log crosses 0 at 1, right? Yes. So it's when 2x plus 1 equals 0, which means 2x equals negative 1, which means x equals negative 1/2 will give us a valid solution. So we'll check here. Negative 1/2 means this goes to no. When this equals 1, which means come on. 2x equals 0, which means x equals 0. When x equals 0, that goes to 1. Okay, so that's our answer for this piece, not this one. So f inverse of 0 also equals 0. That's my answer. It goes 0 both ways. Okay, so now we need to do what is, oh, this is f inverse of 0. What is f prime of 0? Because that's the piece that goes here. So let's do the derivative of the function. So x prime of x equals d dx of x. I'll just scroll down and keep it here. Of x plus 2 natural log of 2x plus 1. Okay, let's just do product rule then. X plus 2 times the derivative of this one, which would be 1 over 2x plus 1 times 2 plus just 1 times the natural log of 2x plus 1. And we're doing this at f prime of 0. So what do we get here? 2x plus 4 over 2x plus 1 plus the natural log of 2x plus 1 with x equaling 0. That goes away, that goes away. We get 4 plus 0 here, natural log 1 is 0. So we get 4. So 4 goes back up to here. So we have this part. So I'm going to say 1/4. I've remembered the reciprocal. I remember the reciprocal. If this isn't right, I might have to take a break. God. There we go. That was a bit of a slog. Last one, and then I get to go. Everyone gets to go. Question number 9. F of x equals 3x plus the square root of x. Okay. It's invertible. Great. What is the inverse function derivative of so f minus 1 prime of 2 equals blank. That's the thing we're solving for. F minus 1 prime equals 1 over f prime of f inverse of 2. Okay, so what's the f inverse of 2? It's when this function equals 2, 3x plus root x means, what is this? Root x is 2 minus 3x. X equals 2 minus 3x squared. 4 minus 6x plus 9x squared is x. Let's rearrange this and throw the x over here. So take away another x. So we get 9x squared minus 7x plus 4 equals 0. This doesn't look particularly nice. What multiplies together to give us 4? Can this be factored nicely? Okay. Let's do 3x, and this is getting to be 7, so it's a 1 and a 4, and they have opposite signs on that? Is that right? Opposite? 3 plus 4. Okay, does that work? So that gives us the first one, minus 3, minus... This doesn't work. That gives us, it's going to be 2 and, it's going to be 9x and x, and 2 and 2. And it's negative 4, which means one of them is negative sign, and it's the one that hits the 9. That's 18, that's too much. Plus 2. Whew. Okay, am I right? Solving the right question here? The inverse of 2 equals whatever is when 2 equals 3x plus the square root of x. Throw that over, square it. And it's 4. 2 minus 3x is times 2 minus 3x. 4 minus 6x minus 6x plus 9x squared. I am not solving the right question. There's my problem. Like, this is just way too hard. So it's 9x squared minus 12x plus 4 equals x. Okay, so this is just simply wrong. So we have to pull that over. So it's 9x squared minus 13x plus 4 equals 0. 6, 6. Okay. How do we multiply this? Okay, so this is 9 plus 4. It gives us this one. Okay, so it's a 9 and a 4. 9x x. The 4 goes here, the 1 goes here. They're both negative because they multiply together, it goes positive. And you double check. 9x squared minus 4 minus 9 is minus 13. This thing. Okay. Wow. So x can equal 1, and it can equal 4/9. Okay, so let's box this as a thing we can do. So there's two values that give us if it's invertible in this way. Is there a 3x plus square root of this thing? X equals 1 and 4/9. This just smells wrong. Nothing's obviously wrong, it just smells wrong. What does this mean? When does this equal 2? When does f of x equal 2? 2 is minus 3x is the square root of x. Square it. Oh, let's check on this one. This could remove a thing. So if this is 1 here, that's 2 minus negative 1 equals negative. Okay, 1's gone. 1 can't be right. Can 4/9 be right? 3 times 4/9 is 12. 12/9, which is less than 18/9. Okay, so x has to be 4/9. Okay, x equals 4/9. We did this. So f minus 1 of 2 equals 4/9. Now we need to do f prime of 4/9 equals what? Then plug into the top one up here as 1 over that. Okay. So f is, let's do f prime now. 3x plus the square root of x. And f prime would be 3 plus 1/2 x to the minus 1/2. Alright. So 1 over 2 times the square root of x. 3 plus this. Okay, so when x is 4/9, we get 3 plus 1 over 2 times the square root of 4/9, which would be 2, good lord. 3 plus 1 on 2 times 2/3. So this would be 4, so 3 plus 3 on 4. 3 3/4, which would be 4 on top. So 12/4 plus 3/4 is 15/4. But this is the thing here. We need to do the inverse of it. So it's 4/15. That is my answer. Oh. Whew. I got that 2 in there. I got everything. I got it all. That's very satisfying to actually get all those moving pieces done. All 19 experience points. That, I earned those 19. Okay, one more victory lap. One more victory lap. Oh, around the chair. Okay, so just a few heads up, or a few thoughts on this. 44 total experience points in this session. Looks like I went for about an hour and 15. And for the first, I guess, 15 of those, or 30-ish of those points, it took me about a minute per experience point. And now overall I got 44 experience points, and it took me, hour and 15 minutes. So slowed down dramatically in that last lesson. But I actually now think I have that lesson drilled into my head about how to do the inverses and the derivatives of the inverses of the functions. All right, well, if you stuck around for that, I really appreciate it. Let me know if you have any questions, feedback, suggestions, just overall impressions, whatever you feel like. Leave a comment. And yeah, with that, I wish you guys the best of luck on your own journey here. I can switch back to just my face. Hopefully it was useful to see me in a slightly weakened state from having a slight cold, driving through some math here. So I had a fun time. It was a lot of work. It's exactly what I signed up for, though. So I enjoyed it. You have a good one. I'll see you in the next one.